Hi guys, just wanted to do a covering video when we talk about modeling with exponentials and logarithms, since quite a few of you looks like will be missing class. This is a worksheet and activity that we will be working on together in class. So if you were in class, you really don't need to go back and watch this video. For the very first problem, we're given a table that shows the atomic number given by x, and then the melting point in degrees measured in Celsius for 5 different alkali metals. We're asked to find a model that fits the data. Given that information in the table, our models are actually already shown and calculated for us. So based on the graphs that you are seeing on here, to decide which of the models fits best, really you are asking yourself which of the lines that you're seeing matches the points best. If we look at the linear, certainly there are quite a few points that are not represented by this line. It looks like the line goes perfectly through one of the points. We have 3 points below and 2 points above. I guess you can consider it evenly distributed, but the distance between the line and each of the points is very, very large. If we look at the quadratic model, now our line is significantly closer to each one of the points. Once again, we have one point that lies perfectly on the graph, but we also have a couple of points that are farther away. If you look at the exponential model, you have 1, 2, 3 points that go through that model really nicely. It is very hard to decide whether the quadratic or exponential would be a better representation simply based off of that. So let's remind ourselves how you can get regressions in the calculator. If you would please take your calculators out and practice this with me. Once you get your calculator started, first thing, go on y equals, and in your graph, you might want to make sure that the plot is highlighted. If it is not currently highlighted, you would go over to plot 1 and then make sure that you highlight it. If you currently have any existing equations, please erase those. So for the next step, we need to input our given data into a list in our calculator. To do that, you would click Stat, and then we have to edit a list. I have some previous data, so if you go up to L2 and hit Clear and Enter, it will clear the whole list for you. Move over to L1, go up to L1, and then hit Clear to delete the old list that you might have stored in your calculator. To input our data, all the x values are going to go in L1. So we have 3, 11, 19, 37, and 55. We need to move over to list 2, and then we can input our y points. 180.5, 97.7, 63.4, 39.3, and 28.4. Just double check, make sure that you have the same number of x points as you have in y points. Every now and then you might skip an enter and have a mismatch. Now that you have all 5 points, you are ready to calculate these regressions. To calculate a regression, you might want to quit out of that first, so second mode will quit out of the screen. You're going to click on Stat. We need to move over to Calc, and then we have to go down to number 4 for linear regression, number 5 for quadratic regression, and then number 0 will be your exponential regression. First, I'm going to record the linear regression. When you record the linear regression, you have to make sure that the x list is L1, your y list is L2. I'm going to go ahead and store that regression. To store it in your calculator, even if you don't see the screen, if you hit vars, move over to yvars, and select function, you can click on y1 to select that function. it will store the actual equation into your y1 in here in your graphs. Don't worry about writing out those steps. I actually have a link for you that writes out the steps on ngrade. So if you hit calculate, it gives you quite a bit of information. One of the things that you see on here is the A and B value, but you also have this R squared and R value. To find which one is the best, remember that we're looking for the smallest R squared. So it might be helpful to write those values out. I'm going to go back into the original worksheet and just write out for the linear. I don't even really need to know what are the A and B values, but we might want to write them out. A is negative 2.4975. B is equal to 144.2975. To compare which of the models is best though, I need to know the R squared. So R squared, I'm going to round to 4 decimal points. It is 0.7323. We're going to repeat this for each one of the models and record what is the R squared value. The R squared is what shows us if this is a good model for our data or not. Let's go ahead and calculate the quadratic function. You would hit Stat on your calculator. You need to move over to Calc and go down to number 5. You're going to keep L1 to be X, L2 to be Y. To store your regression equation, you need to click on vars, move over to yvars, and then select function. This time we're going to store the equation in y2. Let's go ahead and calculate that. We can absolutely write out the A, B, and C values on our worksheet. The part that tells me if this is a good model, though, is the R squared. So I am going to record the R squared is equal to 0.9456, being I'm rounding to the 4th place after the decimal. We're going to repeat this with exponential function. Once again, Stat, move over to Calc. You want to scroll down to number 0, which is your exponential regression. Let's go ahead and save this equation. So click vars, move over to yvars, select function. We're going to store it in y3. When you calculate this model, we get an R squared value of 0.917. That's going to be 918 when we round appropriately. Remember that the R squared, the closer it is to 1, the better this model. It looks like the value of R squared that is closest to 1 is the quadratic model. So from here, we can explain that the quadratic is the best model because it represents our data best. If we go back to the graph and look at this graph, I would definitely say that here we have the least number of points that are far away from the actual graph. When we go back to the exponential, we have a really big distance between this point and the graph. So we should have expected that this is really not going to be the best model. Now if I ask you to give me the actual equation, you can go to your y equals and restore the quadratic under y2. Now you can go down to y2 and copy this equation. I want you to note that when you're storing it in the calculator, it records a huge number of decimal numbers. So really, if you store it in the calculator, you will get a really good model for this equation. Where if we were rounding, it will not be this good of a model. So this is how you would use the calculator. Let's look at another example. We're just going to do 1 and 2. For example number 2, we're given that a sport utility vehicle costs $23,300 new. It has a book value of $12,500 after 2 years. We have to find 2 different models for this case. One of them is linear, and then the other one is exponential. Well, if I were to find a linear model, I might need 2 points. Same thing for exponential, since we will be inputting the exponential model in the calculator. So we need these 2 points. Prior, we were given a table that had values for us. In a problem like this, you really need to be able to come up with 2 points. We have x and we have y. Well, the 2 things that we're given here is the price, and we're also given time in years. When you have a new vehicle, you're really starting at time 0. And we know that the cost is $23,300. 2 years later, so when t is equal to 2, the cost is $12,500. At this point, you can do it algebraically and use the formula to find the slope and then find the actual equation. But remember, the calculator can do that for you. So let's go ahead and input this in the calculator like we did before. We need to go on stat. We have to edit a list. I have a ton of points that I don't need, so I'm going to go over, highlight the list, and erase those points. And now I can input 0 and 2 for my x values, and 23,300 as well as 12,500 for the y values. Now I can go to stat again. Whoops, not second stat, just stat. Move over to calc, and then if you go down to number 4, you would be finding the linear equation. We can store that linear regression by clicking vars, move over to yvars, select function, and then let's store it in y1. This is giving us that the linear model for the SUV value is that the function of time is equal to negative 5,400.
Can you please stop by my office?
Excuse me.
Today, Tracy Racker. Thank you.
Negative 5,400x plus the value of b, which is 23,300. This right here is the linear model for the SUV. We already have the data put in the calculator. We have to go in and calculate the exponential model. Go stat, move over to calc, go down to 0. We're going to store this equation in vars, move over to yvars, function, we're going to store it as y2. When you calculate it, the exponential model that we get is that the function of time is equal to 23,300. Oh, look at that. It is the starting value multiplied by the base. We have a base of 0.7324. I'm rounding to 4th place, to the x power. So now we have found both linear and exponential model. Remember that we stored those in the graphing calculator. So if you click on y equals, you have these equations. On y3, I currently have the old equation, so I'm going to delete that. I have these 2 equations. You can use those equations to complete problem C, and I want you to attempt problem D on your own. Thank you guys. I hope you did great on the PSATs.